and welcome to NASA Launchpad. I'm your host, Caleb Kinchlow. Inflatables aren't a new thing. In fact, you've probably played with inflatables a lot as a kid, because in essence, this is an inflatable. And inflatables aren't even a new concept for NASA and space travel in general. As far back as 1961, concepts for inflatable space stations were being developed. Now, NASA's working on inflatables in the form of heat shields. And this old thing isn't going to cut it. So first things first, just what is this new and improved inflatable technology all about?
Currently, when we send a payload to another planet, we need to slow it down. One of the ways that we can slow it down is to use the atmosphere, if there is an atmosphere at that body. To slow it down, we use drag of the vehicle. Drag of the vehicle is a function of the area. Right now, we have a maximum size payload shroud of about 4.5 meters. So if you want a larger drag diameter to land a larger payload on the planet, you need to figure out some way of deploying that aeroshell to a larger diameter. We've chosen inflatables as our approach. They package very nicely, very similar to a parachute. They package down in a very small volume and can deploy to significantly larger areas.
And like we said, NASA's next-gen inflatables are really unique structures. What makes them so unique? Let's find out. First, let's take a look at the materials they're made of. Inflatables are built using several layers of materials, and each layer has its own purpose.
There are many different parts of an inflatable. So the base part, the inside, the main structure is a silicone liner. Just like a balloon, same thing, it's a rubber type material. It's the point of keeping the nitrogen inside the vehicle. On the outside of that is actually a Kevlar. This is the same stuff that police wear in their bulletproof vests. This, you can see that and a little bit better here. It's the yellow that's here. It is woven material. We keep that interlocked. It gives it a structure. It keeps it within a certain diameter so it doesn't overinflate. And then on the outside of that, we actually have, it's a RTV, a rubberized coating, just like the caulk around your bathtub. This stuff is high temperatures though, so it can take a little bit more thermally than the caulk around your bathtub. And that's pretty much all there is to our inflatable.
The shape of this inflatable is important too. Engineers and researchers know that the blunt-shaped body used in previous capsules works effectively. So how do they go about getting an inflatable to make and keep the right shape?
We stack a series of increasing diameter donuts on top of one another. If you think of the stacking toy you had when you were a toddler, you had a series of different size donuts, and as you stacked them up, it created a cone, either up or down or whatever way you wanted. So we stack the donuts together to get the cone, and then we use adhesives and straps to hold the whole assembly together, and then tie that inflatable structure back to the center body with a series of straps.
Of course, the inflatable isn't pumped up for the whole mission. That means something needs to inflate the structure when it gets to its destination. So how does that happen?
Just like when you go to the store and you get the helium tank and they fill up your balloon, we have a cylinder just like that actually holds nitrogen, and we fill these things up in flight. Series of valves open, and it fills each one of these individually. And they're also linked together so that we make sure we don't overpressurize and they don't pop.
Now, with the inflatable heat shield being a new technology with so many different components, it follows that engineers don't know everything about how it will work. So they have to do tests. And we're not just talking about pencil and paper or even computer simulations.
We've got a lot of different testing that has to go into these vehicles in order to prove them. We are doing wind tunnel testing out at MFAC with a full-size vehicle. We've got 8-foot high temperature testing where we're doing small samples we can do different material configurations for and try to get that information. We also have more complex tests where we test things like the nose caps in a TP2 test facility down at JSC. So we've been doing all kinds of different testing, trying to get the information that we need in order to go to other planets or wherever.
And once inflatable technology is ready to go, there is no telling some of the destinations that could be on NASA's radar. Until then, researchers and engineers will continue their quest to take this technology literally out of this world. That's it for now. Thanks for watching. I'm Caleb Kinchlow. Catch you next time on NASA Launchpad.